Hi everyone, welcome back to our next video in the Excel tutorial demonstration video series. Um, in this video, we're going to be having a look at question 5, or at least the first part of question 5 from the week 4 tutorial. So in particular, what we're going to be having a look at is we're going to be creating some visualizations that we're going to incorporate into our dashboard, right? And in particular, we're going to be trying to make some visualizations that will allow us to answer the following 3 questions. So the first one is, does land size increase as you move further away from the CBD? Next, is there a linear increase in price with more bedrooms, or does it level off? And do newer houses sell for higher prices? So let's get into it. So in order to, actually produce a visualization that is appropriate to answer these questions, we need to have a bit of a think about some of the some of the characteristics of the question that we're being asked, right? So for our first visualization, we're asked, does land size increase as you move further away from the CBD? So the first thing that we need to have a look at is actually identify the variable or the variables that we're interested in making a visualization with, right? Sometimes you'll also see, depending on what you want to show, is there might be a specific sample that you want to show as well. Okay, so both of these need to be identified. Maybe the sample here is for one particular suburb, right? Maybe it's for 4 houses with less than 3 bedrooms. We want to ask this question, okay? So identifying the sample as well as the variables is important. So for us, it's land size, CBD. Looks like we're looking at the whole data set though. Identify the data types of our variables, okay? So this is going to be our next step. Land size and CBD distance are both continuous variables, okay? So continuous versus discrete, or qualitative versus quantitative. There's only certain types of visualizations that are appropriate depending on your data type. So trying to work that out is going to lead nicely into trying to pick an appropriate visualization. The next thing we need to identify is what we want to show. Okay. In this case, we're after a relationship. We're trying to identify a relationship between land size and CBD. And in particular, we suspect that houses tend to get bigger, like the size of these properties tend to get bigger as you move further away from the CBD. Makes sense. Houses close to the CBD might be more expensive. The land might be more valuable. So maybe it gets partitioned into smaller and smaller lots. Okay. So that's what we're trying to show with this relationship. So based on this, right, based on the fact that they're both continuous and we want to show a relationship, a scatter graph is probably useful here. Okay. So when we make a scatter graph, it could look something like this, right? So before I visualized this, some preliminary stuff was done. I filtered out some of those extreme values for the land area. In particular, we saw for the land area, there was one observation in particular that was astronomically larger than the rest of them. That was filtered out. But in addition, I've also filtered out observations above about 1200, right? Just so it's a little bit clearer to see what this relationship looks like. Okay. It appears as though we have some type of negative relationship, right? So against our intuition, where we initially thought that houses further away from the CBD should be larger, actually turns out that there's more variation in the land area further out, but they also on average tend to be bigger, at least based on the suburbs that we have, right? So the answer to that question appears to be no, right? They don't tend to increase a lot, at least based on these 4 suburbs. Okay. All right, so for our next point here, or our next visualization, we've been asked, is there a linear increase in price with more bedrooms, or does it level off, right? So let's go through our steps here. So we start by identifying our variables and our sample. Our sample is the whole data set still, and our variables are the house price and the number of bedrooms. Let's identify the data type here. So house price is a continuous quantitative variable, but bedrooms is discrete. Okay, so being a discrete data type restricts the types of visualizations we could make. What are we trying to show? Well, we're trying to show a relationship again. In particular, we want to see if it's a linear relationship between the two. So based on this, based on the fact that one's discrete, one's continuous, and we want to show a relationship, something that we could create is an average price versus the number of bedrooms. Okay, so calculating an average for our price across our bedrooms and then producing a visualization based on that. There's two main ways that we could show this, right? One would be with a line graph where we show and connect the dots between what the average price is across the number of bedrooms. The other way would be with a bar graph. Okay, so along the x-axis we would have the number of bedrooms, and along the y-axis we would have the average house price. Okay, we're going to opt for a like line graph here. Okay, so let's have a look. So we can see that there's an increasing relationship. I'll hide this real quick. There's an increasing relationship here between the house price, the average house price, and the number of bedrooms. But it doesn't seem to be the case that this is a linear relationship. The second part of our question was that we were interested in the fact that if it levels off or not. So not only is it not linear, it also doesn't level off. It looks as though it's increasing as like the rate at which it increases with the bedrooms, right? It's not linear, it's more of a curve. Okay. But as we saw with the previous question, analyzing our variable or our outcome here in terms of suburb, that was able to give us more information about what was going on. So we could use that here to see what this relationship is. So that's what we do in this second visualization. So we still visualize across the number of bedrooms. We still have a line graph, but this time we're calculating the average price for each of our suburbs here. Right? And when we do this, we can see within each suburb, there appears to be a more linear relationship. Okay, these relationships are more linear. All right. So what's going on? Why is it that each of the suburbs themselves are linear, but this overall visualization is not linear, right? It appears to be the case that for houses with 5 or more bedrooms, right, it appears as though we only really have data from Applecross, right? So because we only really have data from one suburb, and this suburb itself is more expensive than the other 3 suburbs, this appears to have dramatically pulled up the average for the houses between 5 and 9 bedrooms. Okay, so that could explain partly why it looks somewhat flat to begin with between 2 to 4, and then when it's dominated by Applecross, it really takes off. Okay, so if we hadn't done the analysis prior, breaking it up by suburb, we wouldn't have had the intuition to investigate it. Okay, so this is an important lesson. The more time you spend doing data exploration work, the more intuition you will have about an appropriate way to visualize your data. Okay, So the more effort you put into trying to understand the data set you have, the better it'll be, and the more insight you will have into how to properly present it, right? Even if you're asking a completely different question with the data set, right? So invest some time, try and understand what your data is, right? Okay. So our last question here, do newer houses sell for higher prices, right? So we still need to try and work out how to appropriately visualize this. So we're going to start by identifying what our variables are, what our sample is. Our two variables, newer houses, there's a variable in our data set called build year. Build year we could use to determine how old a house was, and also house prices. Okay. Our sample is still all of the observations, so we don't have to restrict it. Identify the data types of our variables. So in this case, we're dealing with two continuous variables, right? And what are we trying to show? Well, once more, we're trying to show a relationship. Based on this, because both of these are continuous and we're trying to show a relationship similar to our first question, we can show a scatter graph, right? It seems as though maybe it's worthwhile breaking up our analysis by suburb. That seems to be a bit of a theme. Maybe we'll be able to learn something doing this. So let's give that a go. All right, so here's our visualization. It's got build year on the x-axis, the house price on the y-axis, and we can see for the four suburbs that we have, what these trends look like. All right. So looking at each suburb individually, I've just reported the R-squareds here. None of them appear to be above 10%, right? So what that means is that build year, regardless of the suburb we're looking at, explains less than 10% of the variation in house price, right? So another way of saying this is there is a very weak relationship between build year and house price. And we can see that visually, right? There doesn't appear to be any trend that we're observing. There's a lot of variation in our data. So it doesn't look as though anything in particular is getting explained by build year. However, what we can notice looking at this visualization is we can notice that there's a lot of variation in terms of when these suburbs were developed, right? So Alkimos looks as though it's a relatively recent build, right? It looks as though these houses were built sometime after 2010. In contrast, Alexander Heights is also a relatively recent development, but it looks as though that started in the 80s, right? Alfred Cove and Applecross look like they're quite old suburbs that have had continuous development over time. Their construction begins in the 1930s. Okay, so it looks as though the types of houses we would expect to see in these suburbs, based on terms of the design, the layout, right? There's probably going to be variation between these suburbs that we're not noticing, right? We don't have any questions in our data set about, is the house like a Queenslander, right? Is it a townhouse, right? About what these specific layouts are. It's likely going to be the case depending on when it was built, could affect like things about the finishing or about the layout. So that's something that we need to keep in mind with our data set. These suburbs are likely going to differ across this. All right. So that does us for the part 1, question 5. I'll see you guys in the last video for the week 4 tutorial.